Hi everyone, in this video I'm continuing to work through question 14 part A of the 2020 Baulkham Hills Extension 1 trial. I've just worked through part 1 in a prior video, so have a look at that if you haven't already, because this part 2 follows on very much from part 1. Here in part 2 we're told that triangle ADO and triangle CFO are congruent, and then we're told to show that the magnitude of WY vector is equal to the magnitude of WZ vector. And we're told to do that by considering the lengths of AD and CF. So yeah, let's take a look. So I've recreated the diagram because if you have watched my prior video on part 1, the diagram was getting pretty crowded. So to kind of remove all the noise, I've recreated it so that I can highlight just the bits that really we care about for this question. And first of all, that's WY and WZ, those vectors, because we care about those magnitudes. So let's annotate that on. So we've got WY vector and WZ vector. So we're ultimately wanting to show that they are the same length, the same magnitude. We're told the triangle ADO, so ADO, and triangle CFO are congruent, and note that they're the two triangles we made use of, ADO and CFO, in part 1. And we're told specifically to consider the length of AD and CF, those two sides of these congruent triangles, to show this result. So maybe if I just draw on, maybe in black, if I draw on AD and CF, in terms of these two congruent triangles, they're the two equal sides of those triangles. They're the two equivalent sides, and therefore we know they're going to be equal. So if we kind of go and look back at part 1, in terms of WZ, we made use of the fact that the magnitude of WZ will be half the magnitude of CF. And given we've got WZ here and CF here, or at least in the hint we've got CF, that's pertinent. And similarly, we did take a look at WY and AD, and we made use of the fact that the magnitude of WY would be half AD, and that's how we could equate these vectors. So really, the way we can tackle this is we could say from part 1, we relied on the fact that the magnitude of WY vector was equal to half the magnitude of AD vector. And we also relied on the fact that the magnitude of WZ vector was equal to a half the magnitude of CF vector. And therefore, if the magnitude of AD vector is equal to the magnitude of CF vector, if that's the case, since triangle ADO is congruent to triangle CFO, well, then we can just we can basically throw these in. If AD is equal to CF, that magnitude, then if we multiply both sides by half, we could say a half magnitude of AD vector is equal to a half magnitude of CF vector, because we haven't changed the equality, we've just multiplied both sides by half, and the reason we want to do that is because now we can know we can throw in WY on this side and WZ on this side. So therefore, this is WY, magnitude of WY vector, and this is WZ, magnitude of WZ vector. And that is as required. Panic boom! That's actually exactly what we were being asked to prove. So yeah, again, potentially daunting, but actually in terms of the working out, very little working out required. What you're really being tested on here is just whether you understand everything that's going on. So hopefully you followed along with that, and that makes sense to you. Again, whilst the working out looks pretty easy, it doesn't mean the question's easy. I think it's actually a tricky one, and it's really testing how well you've solidified all of these vector concepts, given in extension 1 it's probably the first time you're learning them. So yeah, there you have it for that question. In the next video I'll work on part 3, and yeah, tick boom.